Welcome to today's discussion. Today we are going to look at Form 3 chemistry under chlorine and its compounds, but specifically here we are going to look at the manufacture of hydrochloric acid. So the question we have reads, the above diagram shows a setup that can be used for industrial manufacture of hydrochloric acid. Study it and answer the questions that follow. Before we look at the questions, let us try to analyze this diagram. We have excess chlorine and hydrogen gas, and we know when chlorine and hydrogen gas are burned, they give us hydrogen chloride gas. So we have chlorine gas reacting with hydrogen gas, and the reaction between chlorine and hydrogen produces hydrogen chloride gas, which is our product F. If you may wish to balance the two equations, the equation, we write 2 behind hydrogen chloride gas. So product F is hydrogen chloride gas. Then hydrogen chloride gas goes to the absorption tower, where it is reacted with substance E to produce hydrochloric acid, which is taken to the storage tanks. Remember, hydrogen chloride gas is usually diluted with water, which is substance E, to form hydrochloric acid. So let us go through the questions. Name product F. Product F is formed as a result of the reaction between chlorine and hydrogen gas, and this is hydrogen chloride gas. Hydrogen chloride gas. Then we have substance E. In the absorption tower, we have water coming in to react with hydrogen chloride gas to form hydrochloric acid, and therefore substance E is water. Substance E is water. Next, B. Explain one application of hydrochloric acid in textile industry. Remember, hydrochloric acid can be used as a stain remover. Hence, we can say it is used in making bleaches. It is used in making bleaches, or what we can call bleaching agents, which are used to remove stains. C. Hydrochloric acid was added to iron powder in a test tube and shaken thoroughly to mix. To 1 centimeter cubic of the resulting solution, 6 drops of aqueous ammonia solution were added. Remember, we have hydrochloric acid reacting with iron to give us iron 2 chloride, which is a solution, plus hydrogen gas. Remember, in this solution, we have iron 2 ions and chloride ions. Our main concentration is iron 2 ions, and we are adding ammonia solution, or ammonium hydroxide. We need the hydroxide ions, and the reaction between iron 2 ions and hydroxide ions will give us iron 2 hydroxide precipitate. So we are told, state the observation made on adding ammonia solution. We are going to see a green precipitate. A green precipitate, since iron 2 ions are insoluble in aqueous ammonia. Roman 2 of part C, explain the observation stated above and write an ionic equation for the reaction. Remember, we have ion 2 ions. Ion 2 ions reacts with hydroxide ions from ammonia solution to produce a green precipitate of ion 2 hydroxide. In this case now, if you want to do an ionic equation, we are going to take ion 2 ions, aqueous, plus hydroxide ions from ammonia solution to give us ion 2 hydroxide, a solid or simply a green precipitate. And for us to balance the equation, we write 2 behind the hydroxide ions. Remember, this is the test for the cations. The last part of the question, which is part D, says concentrated hydrochloric acid is 35% pure with a density of 1.18 grams per centimeter cubic. Calculate its concentration in moles per liter, that is the molarity of this particular solution. Now, we know 1 centimeter cubic contains a mass of 1.18 grams. So if 1 centimeter cubic contains 1.18 grams, we need to calculate the number of grams or the mass in 1 liter, which is 1,000 centimeter cubic. And to get the mass in 1,000, mass in 1,000 centimeter cubic would be equal to 1.18. We multiply by 1,000, which gives us 1180 grams. From here now, we can calculate the mass of HCl. Mass of HCl would be equal to 35% of the total mass, which is 1180. And this one is going to give us a mass equal to 413 grams. From here we know that the relative formula mass of HCl is 36.5 grams. That is, we have the relative atomic mass of chlorine is 35.5 plus 1 for hydrogen, giving us 36.5. From here now we can calculate the molarity of this, or simply the concentration. Molarity is given by grams per liter. You divide by the relative formula mass. And in this case now, we know the number of grams in 1 liter. We have already calculated them as 413 grams. We divide by the relative formula mass of hydrochloric acid, which is 36.5. And this one is going to give us 11.3151 molar. Thank you for watching and welcome to the channel. And in case you have questions, you can feel free to interact with the channel in the comment section, and we shall be glad to address your concerns accordingly.